On March 12, 1993, regional weather services across the eastern United States operated under normal late winter forecasting protocols. The Southeast prepared for rain. The Mid-Atlantic expected mixed precipitation. The Northeast anticipated routine snow. Standard procedure assumed spatial separation. Southern systems remained southern, northern storms remained northern. The atmospheric boundary between subtropical moisture and Arctic air typically migrated gradually. Infrastructure across 26 states functioned under the assumption that winter storms affected regions sequentially, not simultaneously. No precedent existed in modern meteorological records for a single cyclone delivering blizzard conditions from Alabama to Maine within a 48-hour window. Winter storm response infrastructure in 1993 operated along regional boundaries. Southern states from Louisiana to Georgia maintained minimal snow-clearing equipment designed for infrequent ice events lasting 12 to 24 hours. Mid-Atlantic states stockpiled road salt and maintained plow fleets calibrated for nor'easters producing 10 to 20 inches of snow over coastal corridors. Northern New England systems prepared for prolonged cold and steady accumulation. Electrical grids operated independently by region. Interstate highway systems assumed year-round navigability with temporary weather delays. Commercial aviation hubs in Atlanta, Charlotte, and Newark functioned as connection points vulnerable only to localized closure. No coordination mechanism existed for simultaneous failure across climate zones. The operational assumption was sequential impact. On March 11th, surface analysis detected a low-pressure system forming over the northwestern Gulf of Mexico. Sea surface temperatures measured 2 to 3 degrees above normal. A strong upper-level trough approached from the Pacific Northwest, creating favorable divergence aloft. By 1200 UTC March 12th, central pressure had fallen to 998 millibars near the Florida Panhandle. Precipitable water values exceeded 2 inches across the warm sector, indicating exceptional moisture availability for March. The system drew tropical air northward while Arctic air pushed southward behind a sharp cold front. The collision zone extended from eastern Texas to the Carolina coast. Rapid pressure falls continued through the afternoon. By evening, the low had reached 980 millibars while still over land, an unusual intensification rate for a continental cyclone. Between 000 UTC and 1200 UTC March 13th, the system underwent bombogenesis, pressure falling more than 24 millibars in 24 hours. Central pressure dropped to 960 millibars as the low moved northeast along the Appalachian spine. Wind fields expanded radially. Sustained winds of 40 to 60 miles per hour extended 300 miles from the center. Gusts exceeded 70 miles per hour across the mountains and coastal plain. The pressure gradient between the low and a Canadian high-pressure system intensified, accelerating northerly flow behind the front. Cold air advection rates exceeded standard nor'easter profiles. The low covered 1,400 miles longitudinally by mid-morning March 13th. Explosive deepening combined with rapid forward motion created simultaneous hazard exposure across disconnected climate zones. No warning framework existed for this scale. Snowfall rates reached 2 to 4 inches per hour across the Appalachian corridor beginning late March 12th. Wind speeds of 35 to 50 miles per hour sustained created ground blizzard conditions where snow depth exceeded 6 inches. Visibility dropped below 1/4 mile across portions of 10 states simultaneously. Temperature gradients were severe. Freezing lines shifted southward 150 miles in 6 hours. Rain transitioned to snow across northern Georgia, the Carolinas, and Virginia within a 3-hour window. Snowfall accumulation exceeded 12 inches in Birmingham, Alabama, 18 inches in Asheville, North Carolina, 25 inches in Syracuse, New York. Wind chill values fell below 0 Fahrenheit from Tennessee northward. Blizzard warnings, normally regional, were issued from Alabama to Maine. The combination of deep snow, high winds, and rapid thermal collapse exceeded design parameters for structures and systems across 14 states.
Snowfall across the Deep South exposed infrastructure designed for minimal winter precipitation. Atlanta recorded 4 inches, Birmingham recorded 13 inches, Chattanooga recorded 20 inches. Road surfaces had no chemical pretreatment. Municipal snowplow inventories were insufficient for arterial road clearing. Electrical distribution systems lacked ice load reinforcement common in northern designs. Tree canopies retained leaves in some areas, increasing wind surface area and limb failure rates. Roofs designed for 20-pound snow loads experienced 50-pound wet snow accumulations. Interstate 75 and Interstate 85 became impassable across Georgia and Alabama. Airports in Birmingham, Atlanta, and Knoxville closed on March 13th, remaining shut for 36 to 48 hours. The storm violated a fundamental infrastructure assumption: southern systems would not face northern hazard thresholds. No contingency protocols existed for this scenario.
By midday March 13, Interstate 95 from Florida to New York, Interstate 81 from Tennessee to Pennsylvania, and Interstate 77 from South Carolina to West Virginia were closed or impassable. Stranded vehicle counts exceeded 10,000. Hartsfield-Jackson Atlanta International Airport suspended operations March 13, affecting connecting flights across the national network. Newark, LaGuardia, Kennedy, Philadelphia, and Charlotte airports closed. Cumulative flight cancellations exceeded 3,000. Amtrak suspended service along the Eastern Corridor. Freight rail operations halted across 6 states due to snow accumulation on tracks and switching equipment failure. Port operations in Savannah, Charleston, and Norfolk stopped due to storm surge and wind. The system disabled all primary north-south transportation corridors simultaneously. No redundancy existed. Cargo, passengers, and emergency vehicles had no alternate routing for 72 hours across a region containing 100 million people. Peak wind gusts caused widespread electrical failures. Overnight, March 12 through 13, 3 million customers lost power across the Southeast. By March 14, total outages reached 10 million customers across 13 states. Restoration timelines extended beyond 1 week in mountainous terrain where road access remained blocked. Coastal zones experienced storm surge of 6 to 12 feet, despite the system being classified as extratropical. Flooding occurred simultaneously with snowfall in Florida, Georgia, and the Carolinas. Dauphin Island, Alabama, recorded a 12-foot surge. Evacuation orders affected 50,000 coastal residents. The combination of snow inland and surge on coasts fragmented emergency response resources. Utilities prioritized densely populated areas. Rural communities in Appalachia remained without power for 10 to 14 days. Cold exposure became a secondary hazard as heating systems failed during sub-freezing conditions. The storm affected approximately 100 million people across portions of 26 states. Confirmed fatalities exceeded 270, with causes including exposure, traffic accidents, and coastal drowning. Economic losses were estimated at $5 to $6 billion, including infrastructure damage, lost commerce, and emergency response costs. Snowfall totals exceeded 40 inches in portions of the Appalachian Mountains. Syracuse, New York recorded 43 inches. Mount LeConte, Tennessee recorded 60 inches. Duration of impact varied. Southern regions experienced 12 to 36 hours of operational shutdown. Northern zones remained disrupted for 72 to 96 hours. Schools across 14 states closed for 3 to 5 days. Federal disaster declarations covered 11 states. The storm demonstrated that single-system continental-scale failures could occur outside tornado outbreak or hurricane scenarios, exposing gaps in multi-regional coordination and resource prepositioning. Recovery operations began sequentially as conditions allowed. Southern states prioritized interstate highway clearing beginning March 14th. Snowmelt accelerated in areas where temperatures rose above freezing within 48 hours, complicating drainage and creating secondary flooding. Northern regions required mechanical snow removal lasting 1 to 2 weeks. National Guard units deployed in 12 states to assist with road clearing, power restoration, and supply delivery.
FEMA coordinated resource distribution across a geographically fragmented disaster zone. Electrical utilities mobilized crews from unaffected regions, but access delays due to road conditions extended restoration timelines. Airports resumed limited operations March 14 through 15, with full schedules restored by March 17. Rail freight resumed March 16 on cleared primary corridors. Coastal cleanup continued for weeks. Total recovery duration exceeded 3 weeks in the most affected Appalachian communities.
The National Weather Service classified the event as a superstorm due to its geographical scope, intensity, and multi-hazard profile. Central pressure of 960 millibars ranked among the lowest recorded for non-tropical cyclones affecting the eastern United States. The storm held blizzard conditions across the largest continuous area in U.S. history. Meteorological records documented snowfall in 44 of the 50 states during the event window, including trace amounts in California and Oklahoma. The event became a benchmark for revising winter storm forecasting protocols, emergency management coordination frameworks, and infrastructure resilience standards across climate transition zones. Post-event analysis identified the lack of unified warning systems and real-time resource sharing agreements as critical vulnerabilities. The blizzard of 1993 remains the standard reference for continental-scale winter system impacts in operational meteorology and emergency planning.